Hello everyone. Today I'll start with class 9 number system, the fourth part. Today we are going to do irrational numbers. We are going to see some of the important parts of irrational number, and then this is an introduction video of topic irrational number. So topic is irrational number. Introduction. So in the next video I'll show you the questions. Irrational number. Before that, you should know what is rational number. What is a rational number? Any number of the form p by q. Any number which has a numerator and denominator. Remember, the numerator and denominator are integers. And this q can never be equal to 0. This is for what? Rational number. Rational number is q. Rational number. But we are doing irrational number. Let's see what is irrational. Very simple. Very simple. What is irrational? A number which is not of the form p by q. Which is not of the form p by q. Now, which is not of the form p by q is called irrational number and is denoted by q on the top bar. Bar means not q. Means not rational. Is irrational. Okay? And rational number, this is just a brief idea of rational number. Rational number, what it has? It has a terminating decimal expansion, or if it doesn't terminate, it will repeat. Non-terminating decimal expansion. Non-terminating, repeating decimal expansion. Remember, this is for rational number. Rational number, the division process, it will end. Okay? And if it doesn't end, it will repeat after certain steps of division. You will see that the number starts coming repeating. Okay? So if it doesn't terminate, it will repeat. So that is for rational. And what is for irrational? Irrational is what? It has a what? Non-terminating, non-repeating. Remember, non-terminating, non-repeating decimal expansion. Okay, irrational number, the division process, what it happens? It will never terminate and it will never repeat. Non-terminating, non-repeating decimal expansion. Okay, so example of irrational number, like whatever comes inside the root, whatever is the root, square root, cube root, whatever it comes, square root of 2, it is irrational. It cannot come out of the root. Square root of 5, irrational. Square root of 21, irrational. Square root of 50, irrational. Okay? Like for some numbers, let's say square root of 8. Square root of 8, I can write 8 as what? I can write in terms of factors 2 square into 2. Remember 8, square root of 8. 2 4s are 8 and 2 2s are 2. Then I can write 2 square into 2. Then this 2 comes out and here it is, square root of 2. Remember, 2 is rational but is multiplied with irrational. It becomes irrational. So these are the certain examples of irrational. So I'll do some properties of irrational. Just see. Rational added or subtracted with irrational. is irrational. Remember, if you add a rational number or if you subtract a rational number with irrational, the output becomes irrational only. Like example, 2 is rational, add it, any irrational, let's say root 5. The output as a whole, it becomes irrational. Q0. Q0 means irrational. Subtraction also same. If you put here subtraction also same. Rational subtracted with irrational, it is irrational. The output, the total thing. Don't go individually. This is rational. This is irrational. The output, the total, it is irrational. Remember that. Now, this is point number 1. You can note it down. Point number 2 is what? Rational multiplied or divided with irrational. Yes, irrational. Same way. If you multiply rational with irrational, or if you divide rational by irrational, or irrational by rational, same meaning. The output is what? Irrational. Like let's say 7 rational multiplied with root 7 or root let's say root 3. Irrational. Rational, if nothing is there, multiplication, don't write in between here. You don't write inside this separately. This means multiply. 7 is multiplied with root 3. The output rational, irrational. But as a whole, this as a whole is called irrational number. Remember that. Same case with division also. Same case with division. Division is what? Rational divided by irrational, root 5. The output is irrational. Or root 5 divided by 7, it is irrational. Remember this small points so that you will not have any problem in future. Okay. Then how to prove something is irrational? I am going to show you today a very important point, how to prove that something is irrational. Let me try with square root of 2. Now you know that root 2 is what? Rational or irrational? Root 2 is irrational. Okay? But how to prove it is irrational? Remember I told you, irrational number has non-terminating and non-repeating decimal expansion. Using that I'll prove it, and another way also I'll prove it. 2 methods I'll prove it. Now method number one is called what? Division process. Okay? Let me find out the square root of 2. Square root of 2. This procedure, square root, how to find out? I'll write here 2, and remember that 2 will not be enough, so I'll write here point. After point you can insert so many zeros, as many you want, but try to write down in pair. 2. Now pair it from behind. 2. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. You can write thousands and thousands. 0, 0 paired, 0, 0 paired, 0, 0 paired, and 2 doesn't have a pair, so we have to take it single. Now, whatever you choose here, you have to write down. I'm teaching you how to find out the square root at the same time. Whatever you write here, you have to write the same thing. It's not that 1 2s are 2 or 2 1s are 2. Not like that. If you write here 1, you have to write here 1. If you write here 2, you have to write here 2. 2 2s are 4. This is too small for that. So 1 1s are 1. So after that, subtract. 2 minus 1, 1. Now the next divisor will be the double of this. Means I add 1 here. 1 plus 1 is what? 2, and one more I need here. Always you double this and keep a space here. Now here will be 2 digit and here is just 1 digit. This is too small to be divided. What I'll do, I'll bring down this double 0. And remember, double 0 is where? After the point. So insert here point in the quotient. Now next, 2 how many times? Suppose here, if you write here 2, here also you have to write 2. 22 2. If you write 1, 21 1. Not 21 21. Whatever you write here, that's why I underline this one. If you write here 2, here also 2. But not 2 2s are 4. 22 2s are 44, like that. So I will choose here 24 into 4. If I put here 4, here also 4. 4 4s are 16, 1, 4 2s are 8, 9. So this will be perfect. Because 25, 5 is 125. So 4 here. So here also 4. This becomes 196. Now what happens here? I'll subtract 4 and 9 minus 9 is 0. Then I have to double this 4, not this, only the ones digit, means plus 4. 4 plus 4, 8. Always write little this side, keep a space here. And here this is 2 only. And this here will be 3 digit and here just 1 digit 2 less. I'll bring down this double 0 down. And see here, if you put here 2, here also 2. 2, 8, 2 into 2. This will be too small for that. So 1, here 1. If you put here 2, see, 2 2s are 4, 2 8s are 16, 2 2s are 4 plus 1, 5. So this will be too small for that. So I put here 1. So this becomes 281. Subtract again. This becomes 9. 9 minus 8 is 1. And 3 minus 2 is also 1. And I double this 1 plus 1. I'll write little this side. 1 plus 1 is 2. Keep a space here. Here 8 and here 2. And here will be 4 digit. Here just 3 digit 2 less. Bring down this double 0. You can bring down only once. Okay. You cannot bring twice double 0. Only once. And let's see here. Here 5 digits we have. Here 3 digits. It will be 4 digits. Let's see which one is the perfect one. 2, 8, 2. How many times I can write? 4 into 4, how much? Let's see. 4 4s are 16, 1 remainder, 4 2s are 8, 9. 4 8s are 32, 2, 3. 4 2s are 8 plus 3 is 11. 11296, 11900. I think this will be perfect. 5 5s will be too big. If I put here 5, it will be too big. So let me put here 4 only. So things looks like it will repeat. No, 4 is already there. Maybe 4 1 if it comes 4 1 means it is not irrational. It becomes rational. Let's see what happens here. 1 1 2 9 6. Let's see what is the next. Dividend will subtract this one. This will become 4. This will become 9. 9 minus 9 is 0. And this becomes 8. 8 minus 2 is 6. And what I choose here? I choose here 4. I forgot here 4. And bring down this double 0 again. And you add 4 means you double this ones. This is 4 plus 4 is 8. 1 nothing remains. 2 8 2. And keep a space here. So you see here what I'll do here. 2 8 2 8. Here also I have to put 1 digit here. And here 5 digit. Here also 5 digit. So you have to be very careful regarding this what to put. If you put here 1. If you put here 2. Let's see into 2. Let's see. 2 2s are 4. 2 8s are 16. 1. 2 2s are 4. 5. 2 8s are 16. 1. 2 2s are 4. 5. I think this will be the perfect one. Perfect one. Here 2 and here also 2. Nearest to 5. If you put here, if you put here 3. Okay. Just check. 3 2s are 6. And here already the number will be big. So you can try with 3 also if you want, but it will not be enough. So this will be 5 6 5 6 4. Now you see, I'm not going to continue anymore. You like this, you keep on doing. You just check. After 4 we got 2. Had it been 4 1 4 1 4 1 like that, we can see that okay, it is rational. But here we have seen that okay, you keep on dividing, you keep on choosing the number here. Because zeros, don't think that 0 is enough. We have so many zeros. You bring down so many zeros, you'll find that it will never end. And nothing will be repeated. Repetition will not be there. Okay, 4 once it will come, but a group of number will not repeat. Or one single number will not repeat again and again. So that's why it's called irrational. Why it is called irrational? Because square root of 2 is 1.4142, like that. It doesn't end. So it is irrational. Okay, this is one way of proving that it is irrational. What will you write? Since the division or the square root of 2 has non-terminating and non-repeating decimal expansion, therefore square root of 2 is called irrational number. You can write that. Okay. Now this is one way of proving. So let me try with another way. Method number 2. Method number 2. Okay, one more thing. Suppose I have done like this: 5.30, 300, 300, and 3 4 zeros. Like this, if it continues, no, what happens? 4 zeros, and then you have 3. Like this, it keeps on continuing. Check. It is rational or irrational by looking the decimal expansion. Just check. 5.30. 30, fine. After that 300. Okay. After that 300. After that 3 4 times 0. So which means what? It is non-terminating and non-repeating. Don't think that it's repeating. Don't think that 30 is repeating. If 30 is repeating, everywhere you get 30, 30, 30, 30 like that. But here 30, 300, 300, 3 4 times 0 like that. It is non-terminating, non-repeating. So this type of decimal expansion is called irrational number. Okay, non-terminating, non-repeating. So this number is called irrational number. Don't think that it's rational. You may get confused, but now you know it. You should not get confused. Now method number 2. Method number 2. Method number 2. Like one way I proved, no, square root of 2. Square root of 2 is what? Irrational number by doing long division method. Now I'll prove by another method. Very interesting method. You have to focus. Now method number 2. Square root of 2. How to prove it is irrational number. Okay. Now what will I do now? Suppose, let me assume that I'll do by contradiction method. Okay. In maths, it's not that square root of 2 you have to prove it's irrational number. Directly you can prove it. No, sometimes we have to go in the other way also. I will assume that square root of 2 is rational. But ultimately you will reach to a point that, okay, whatever I assume it is wrong. Whatever I assume it is wrong. Then it becomes irrational. So this is called contradiction method. Contradiction. Remember, contradiction. Contradiction. Contradiction means whatever you assume it, and at the end it is not showing the same thing. It is giving you false. So that is called contradiction. Remember that. So let me do it by contradiction method. Method number 2 is contradiction method. Contradiction method. Contradiction method. Now see it very carefully. Very interesting. So many new things you will learn. Okay. So I will do it what? Let square root of 2 be rational number. Remember my assumption. Square root of 2 be what? Rational number. I assume it. Square root of 2 is rational number. Now you remember, if anything is rational number, it can be expressed in the form what? P by Q. Okay. So let me say, which implies, if this is rational number, which implies square root of 2 is equal to P by Q. Any number of the form P by Q is called rational number. So I assume that square root of 2 is rational number. So square root of 2 is of the form P by Q. Okay. What is P by Q? P by Q, P and Q are integers, and it is in simplest form. Simplest form. Simplest form means what? After that you cannot cancel it. Okay? It is in simplest form. Like 6 by 8. It is not in simplest form because I can cancel it 2 3 times and 2 4 times. I can write that, okay, 3 by 4 is what? Is in simplest form. So same way, P by Q, it is in simplest form. Means, you cannot cancel by any other numbers. Remember, whatever I am telling you, keep that in your mind. That will help you in future. Suddenly I'll come to that point, okay, I may not tell you again and again, P and Q are integers and it is in simplest form. Now you remember that. Square root of 2 means P by Q. Why? Why square root of 2 is P by Q? Because I assume that square root of 2 to be what? Rational. I am doing contradiction method. Contradiction, at the end I'll prove that, okay, whatever assumption is wrong. So now I assume that square root of 2 is rational. So that means square root of 2 equals to P by Q. And what is P by Q? P and Q are integers and is in what? Simplest form. Means you cannot cancel P by Q. Remember, as a whole P by Q you cannot cancel. Okay? It is in simplest form. Now what will I do now? Now just check. I will just cross multiply this one. Just cross multiply. Square root of 2 into Q equal to P. Till here clear? Now what does it implies? What does it implies? Now it implies what? Suppose I want to remove this square root. I'm squaring both sides. What will I do now? Squaring both sides. Remember, I'm doing very important point for you. Squaring both sides. Squaring both sides, it becomes what? Square root of 2Q square equals to P square. Now I square both sides. I give whole square to both. Now which implies, as these two are multiplied, no, square will go to both. Square root of 2 square into Q square equal. If there is a plus or minus, no, square cannot go to both directly. If there is a plus or minus, if there is a into or division, square or any power goes inside very easy. Okay. You can just pause the video so that you can see. You can note it down. Just pause the video to note it down. Now, till here I think everything is clear. Now square root of 2 square and square root get cancelled. It becomes 2Q square is equal to P square. Check. 2Q square is equal to P square. What it implies? Just see. 2Q square equals to P square. Now P square equals to 2 into something. Just check. P square is equal to 2 into something. Check. 2 into Q square. Point to be noted here is 2. That means what? That means what? P square is even or odd. Check. Suppose I say 6. See, okay? 6 square. 6 square is what? 6 square is 36, no? 36, no? 36. 36 is what? Okay, forget about square first. 6 equals to what? 6 equals to 2 into 3. No? I can write that. So anything which is multiplied by 2, no? Whatever is the number output, after I multiply by 2, this number becomes even number or not? It becomes even number or not? Tell me. It's an even number. Multiple of 2. Even number. Like, let's say 9. 9 I can write 2 into something? No, I cannot write. That's why it is not an even number. Example, let's say 100. 100 can I write 2 into something? Obviously, 2 into 50. Because of those 2, it becomes even number. Check. So what is even number? 100 is even number. Because why? 100 we can write it, we can express in the form what? 2 into something. So this 100 becomes what? Even number. Check. Even number. It's a multiple of 2. Now what can I write here? What can I write here? P square is even. Correct or not? P square is even or not? Done? Now, if P square is even, if anything square is even, does it not it implies P is also even? Check. Example. Okay? Let's see. 6 square is 36. 6. 6 square is what? Even. Correct? Now, is it not 6 is also even? Take it any square. Suppose it if it gives you even, then the number which you square it, that number is also even. Check. 4 square. 4 square is what? 16. 16 is even, no? 16 is even, right? 16 is even. That means this 4, is it not? It is even. Correct or not? Yes. See, here it is written in terms of letters. That's why you may not understand. But things are very simple. Try to understand. Always I give you examples so that you can have a clear picture. Now, p square is even implies p is also even. Correct? Till here. You can just pause the video and note it down, whatever is written. Now p is also even. Remember, p is also even. P is even means what? Which implies what? P is even means p is also multiple of 2. Correct or not? Yes? 6 square is even. Yes? Means 6 square can be written as 2 into something. Now 6 square is what? 36, no? 36 is what? 36 is what? 2 into 18. Correct? Because of this 2, this 6 square becomes what? Even. Now I imply that okay, 6 is also even. And 6 also can be written as 2 into 3. Because of this, 6 becomes even. That's why whatever is even, no, is a multiple of 2. So can't I write if p square is even, p is even, which implies p equals to 2m. 2 into something, m can be anything because I don't know what is p. And m can be anything. M is, let me assume here is positive what? Integer. I'm just assuming positive. I'm not doing for negative here. Okay? Positive integer. M is any positive integer. Okay? Any positive. That doesn't matter. Even in odd case, positive or negative doesn't matter. But here, I'm assuming p equal to 2m. Is it clear? Because if p is an even number, if p is an even number, p equal to some multiple of 2. So 2 into something, that something doesn't matter. It can be even, it can be odd. That doesn't matter. But I'm interested in this 2. Because p is even, I have to write 2 into something. So 2 into m. Okay, here too I know 6 is what? 2 into 3. So I could write here 3. But here do you know what is p? That's why I'm writing m. Don't get confused. Okay. Now let me square again. Let me square again this one. So where is it? This one. Suppose this one is my equation number 1. 2q square equals to p square. So wherever is equation number 1, you can just note it down. Now let me do squaring again both sides. Squaring both sides. Squaring both sides. Squaring both sides. It becomes what? P square equals to 2m square, which is equal to 2 square is 4 and m square is m square. I already told you. Now I'll rub this one. This is equation number 2. Now I'll put this p square equals to what? 4m square here in equation number 1. Therefore 1 becomes what? 2q square is equal to, in place of p square I'll put 4m square. Now this 2 let it go down. Q square equals to 4 by 2 m square. Now q square is equal to what? 2m square. Correct or not? Tell me, q square, is it even or what? Q square is also a multiple of 2 now, which implies what? Q square is even, because multiple of 2. Q square equals to 2 into something, so q square is even, which implies what? Q is also even. Yes. Now what can I refer from both the things? Both. Try to see what I proved. I proved that P is even and Q is also even. So what was my assumption? my assumption that P by Q is in what? Simplest form, means it cannot be cancelled. That was my assumption. Means they don't have any common factors. That is called simplest form. They don't have any common factors. But now what did I prove? What did I prove? Tell me that. I have proved that P is even and Q is also even. So for sure there is a common factor which is 2. Because even number, say 6 is even number. No, another even number, let's say 10. Is this in simplest form? No, they have common factor. Means I can cancel it by 2. Because I can write this one as 2 into 3. This one I can write 2 into 5. So my assumption was wrong. What did I assume it? They don't have any common factors. It is in simplest form. But now what did I prove it? I proved that when I assume that, okay, that was rational. That was rational, no? Yes or no? Now what happens? I am contradicting. Means square root of 2 is rational. I assume that it is rational. It is of the form P by Q, which doesn't have any common factor. Okay, it is in simplest form. But now what am I getting? I am getting that P is even and Q is also even. Just check. So whatever is the assumption, is it not wrong? It's wrong, no? So due to that, square root of 2 becomes irrational number because my assumption was wrong. Remember, I am doing contradiction method. Okay, we have seen that P and Q are even numbers which contradicts our assumption. What was our assumption? P by Q is rational number. So after that we started doing. So which means what? Therefore, square root of 2 is irrational number. So this is the second method how to prove that something is irrational number. Very easy. Okay. So I think things are clear how to prove that square root of anything, it is rational. I give you two methods. One is long division method. Another method is what? Contradiction method. So you can try. Now you tell me, square root of 9 is rational or irrational? It's rational. If something can come out, square root of 9 is 3 square. Is 3. Rational. Now square root of 25. Rational or irrational? Square root of 25 is 5. Is rational. Because square root of 25 is 5 square. Square root. Answer is 5. Now square root of let's say 50. 50 I can write 5 square into 2. Remember 50, what can I write? 225 and 5. 5 has a pair but 2 doesn't have a pair. So 5, it doesn't mean square and square root you can cancel because square root will go to both because there are two parts now. Square root will go to both. Square root of 5 square into square root of 2. Now square root of 5 square cancelled. 5 root 2. Rational or irrational? This is irrational. I already told you. Rational multiplied with irrational, output is irrational. Remember, this is irrational. Now you have to know some identities, algebraic identities. A plus B whole square is equal to A square plus 2AB plus B square. A minus B whole square is equal to A square minus 2AB plus B square, and A plus B product with A minus B is equal to A square minus B square. You may need these identities in future, so I am giving you beforehand what are the important points. So this is how we can check something is rational or irrational. and after that you have to remember these identities, because in the exercise I'll be using these are very familiar for you. Class 8 you have already done, so just a quick revision whatever you have done in class 8. A small idea, whatever required I'll give you again, okay? Alright then. Okay, that's all for the introduction part. Now what we'll do, we'll start with the exercise in the next video, okay? Now before that, go through all the points whatever I give you and prove by yourself that, okay, how square root of 5, prove by two methods, okay? Square root of 5, take any number, okay? Square root of 5, it is irrational. Prove this one. Prove by yourself that this is irrational by any method. Long division method also you can do, or by contradiction method also you can do. Okay? Now, thank you.